Okay, hey everyone. So I'm here to demonstrate how to use React to build AR applications. And if you guys have been following the news lately, you know that AR has become kind of maybe the next big thing. Apple just announced ARKit, which comes out tomorrow. That lets people build AR applications. Then Facebook and Google and Microsoft and everyone else is following, or they're working on it before and they're following. So there's a lot of new stuff happening in this area. So what I'm going to do is show you how to build AR in React and talk a little bit about what AR is and how you program for it. So we're going to just dive right in. Before I get to all that, just a little bit about who I am. I've been working on platforms for visualization for the last 10 to 15 years, originally making maps through a company called UpNext. We sold that to Amazon in 2012. Where I then worked on the Fire phone, so you should take everything I say with a grain of salt. At Amazon, though, once we were done with that debacle, I got to work on client rendering software, and we faced this challenge where every one of our apps, retail, et cetera, we had to program for iOS and program for Android. And so that's when I first got introduced to React and started trying to get people at Amazon to use it. I left just as they were transitioning, but they were moving a lot of their apps over to React Native. So when I left, that was when VR was starting to get really big, or there was a lot of hype around it. And we thought, there are going to be all of these platforms for VR, but you're going to have to learn all these different languages to program them, like Oculus, HTC, all have different programming paradigms. So we built this platform called Viro, which is based in React and allows you to build VR applications. And so that was VR, and now everyone's talking about AR. So the big question we always get is, why is everyone talking about AR now? Well, one problem, these are both fields of the same umbrella term I use called spatial computing. One half of spatial computing is VR, where you basically put an opaque piece of glass on your face and divorce yourself from the real world, and you're somewhere else, like Total Recall. AR is when you put a transparent piece of glass on your face, so you're actually adding virtual objects to the real world, so it tells you more about the world around you. And to be honest, everyone shifted to AR because VR was taking a pretty long time to get traction. It turns out most people get motion sick. You need a pretty heavy, pretty hardcore setup. You need like a 10 by 10 room to get an HTC Vive working. So VR is still coming along, but it's taking a while. In the meantime, Snapchat came out of nowhere and started letting people put little reindeer noses and crowns on their faces. And people realized that, wow, people actually want to do these things. And it's actually possible using mobile phone technology. And Pokemon Go came around, and that started getting people excited about it too. So suddenly you had, the right setting for all this to happen. Because unlike with VR, with AR, all you need is your mobile phone. So what exactly is involved in building AR? There's two main components. One is you need a tracking engine. And a tracking engine is basically something that can understand the world around you and know where it is in relation to its environment. So the iPad, for example, is powerful enough now to be an actual tracking device because you can use its camera and computer vision to understand. It can understand where it is using that and its motion processor. So if I move it a little bit to the left, it's tracking all your faces, and it says, oh, they moved this far away. I'm guessing I moved this far. And so it's pretty advanced stuff, and luckily we didn't have to do any of that. Apple did all that with ARKit, and Google's doing all of that with AR Core. And then there are a number of other companies that before these guys were doing this stuff. The second part of AR is you need a rendering engine, because even if you could track the world, you need some way to actually draw virtual objects on the real world. And there are a bunch of different options for doing this. SceneKit is the one that Apple built, and it's the one that a lot of people will be using when iOS 11 comes out tomorrow. Its biggest issue is it's not cross-platform, but it does have all the rendering features you'd want, like lighting and shadows, which are really important for orienting objects in space, physics and particles for like fireworks and fun effects, layouts and animations for displaying just 2D content for users. And that's it. And so Unity, though, is the next one where a lot of people are using. And it's a full-fledged game engine. So it comes with a lot of power, you know, rendering physics, everything. But it also has all this game stuff that you don't need for AR, because a lot of AR developers are going to want to be just writing applications. And you're not going to want to learn Unity or Unreal. It's kind of like diving into a flight, into a cockpit of an airplane. It's a whole new paradigm of programming. Viro, you know, it happens to have yeses on all these things. Its biggest yes is that it's React-based, which is especially important for this community. So before we go any further, I'm just going to show a demo of an AR app that we built using React and Viro. Let me get this recording working. Okay. All right, this app is called Figment. And so you can see here, it's my camera. You can see yourselves. And this app is not exactly world-changing, but it does let you do stuff like put a dog on the floor there. This is actually modeled after my own black pug. And you can move it around the stage. It's actually alarmingly large. And you can see as I move my iPad, it's tracking its location. So it actually appears to be there. For those of you who have dogs, you know a lot of it involves doing this kind of thing. You could also use AR to, you know, decorate your home. Added some flowers to this table. And you can imagine people building applications to like see furniture in your apartment, see what that might look like, things of that sort. And other more serious applications, like Walmart's apparently using this kind of technology to help people restock shelves. Amazon's obviously using it for a lot of things. A lot of people are thinking about using it for fashion, so you could try on all these things before you buy them. A lot of applications for this stuff, especially when the technology moves from a device into glasses, which is going to happen eventually. Oh yeah, this is just a little video of some of the other things that we did with this app, but it's basically the same thing, throwing objects on the world, and adding effects. These are called portals, where you can like walk through them, then turn around, and then you can see the real world through your portal again. So once this thing is on your glasses, you'll have those kinds of weird abilities. Let's see. Okay, so how is this kind of app built? So it's built using React Native and React Viro. React Native is used to create all the 2D elements. We didn't reinvent any wheels here. You can use all the power of React Native to do the whole 2D UI of your app. Then you use React Viro to do all the 3D stuff, and all within the same application. That means you can effectively also write an application that has an AR-enabled portion. Like if you turn your phone into landscape, it could activate AR mode versus portrait can be normal mode. Things like that. You can create these hybrid applications. So now I'm going to actually show how this is done. I'm not going to actually live code it, even though that's everyone's favorite spectator sport. I wasn't sure what the Wi-Fi situation would be like. So instead, I'm just going to go through some basic just building blocks to create a really simple application. This is a hello world, which you could maybe sort of see, but it should look pretty familiar to React Native developers. Instead of a view, you have a scene. And all we do there is we add a text. All of our things are pre-penned with Viro, so like normally it'd be text, it's just Viro text, and you position it using a 3D coordinate system. And so this is what that ends up looking like. You just have a hello world, and that hello world is actually floating in real space. It's 4 meters away, because I set that to 4 over there. So now let's get a little more complicated. We're going to add a 3D object to the world. And to do that, we just add a Viro box component. There are a number of components you can use, and again, we center it somewhere in 3D space. And then we add a texture to it, which is basically an image that wraps around the object. And here's what that box ends up looking like. And again, it's sitting there in 3D. If we want to get a little more interesting, because nobody's really going to use an app like that, we can add an actual 3D object. So to use 3D objects, first you need to get to know someone who makes 3D objects, and 3D graphics programmers, or you can download a lot of these things online. And in this example, I'm just going to add a little smiling emoji to the scene. And I'm also going to add a light, a spotlight above the emoji so that it looks more like an actual real thing. You can't make a smiling emoji really look like a real thing, but I think you know what I'm trying to say. So there it is. There's this guy, and you can see that light shining down on the top of his head. So if you want to get even further than that, you can now start to integrate AR into this, because for now we've just been throwing 3D objects at arbitrary points. But what you really do with AR is twofold. One is you read the scene, so you try to interpret the scene around you and identify objects, and then you lay out things in relation to those. So for example, suppose you were trying to write an app that showed people how to play piano. You would have to recognize all the piano keys and then highlight the ones you're supposed to hit or whatever. I actually don't play piano, so I'm just making this up. But in this case, with the most simple type of recognizer that we have is called a plane selector. This thing identifies horizontal planes, then allows you to place objects in relation to those planes. And those of you who've watched like Apple's keynotes and stuff saw that they were doing this a lot. Like you can create a plane and then put a game on top of it. And I'll show you what that looks like here, where you use this component called a plane selector. And inside of the plane selector component, you add in what you want to appear there. And so I'll show you what that looks like. So now we're in plane selection mode, and you can see the system's telling me that it located a plane here. And if I look at this table, it should say that it locates a plane on the table. It looks like it found one underneath the table, but yeah, there it is. So if I tap on that, then it adds this guy on top of that plane. And then you could do what you want with it from there. So that's how you do the most simple kind of layout of things in relation to the real world. Now, things get more interesting when you start adding shadows, because then it starts to, the last emoji I showed you, it looked like it was just sort of kind of floating over the table, but it didn't really look like it was on the table. And this is why shadows are so important, is they allow you to actually show the user where that object is. You start to get a new appreciation for lighting and shadows once you start working in 3D. So I'll show you what it looks like when I select a plane again, and this time it's going to put a shadow underneath it. So now you could tell that this it switched to an angry emoji, but he's actually on top of that thing. And it really makes a world of a difference, the whole shadowing thing. And then some more basic stuff, like this is a full-featured 3D renderer that you can work with. You can do things like animate objects, you can add particle systems, you can interact with objects, you can add physics so that you throw an emoji, and like you could do like emoji bowling. You could do all kinds of funny things. This is another really simple example here where I'm going to make that box that I showed you initially just rotate. So using a simple API just to show that these worlds you create are fully animatable and they're fully dynamic. And then finally, one last demo here is interacting with objects, which is going to be, AR is so early that we don't know what people are going to make with this stuff. So there's just a ton of tools out there, and I'm excited to see what people do. In this example, I'm basically creating an emoji, again, which I don't know where it went, to be honest. Maybe it disappeared. Well, yeah, he's nowhere to be found. Anyway, what that guy's supposed to do is be draggable, but I could actually show you that better just using this app where, let's try something different. Birthday cake, maybe. That's not working. Oh, this box. So I can drag this thing, and the dragging it tries to actually drag over the real world. Who knows if it detects this plane, then as I move it, see it, now it's on top of the table. So this is called real world dragging. And that just can be useful for if you made that furniture app, for example, to move stuff around, or you're placing objects in general. So that's what I wanted to show you. And this stuff is all free, of course, so you can go here and check it out and just start messing around. It's really fun. It's like a whole new programming paradigm. So like our whole team's had a lot of fun just making this stuff. This platform is all available now. You could also use it to make VR, which I didn't talk about, but VR is still a thing. And iOS 11 comes out tomorrow, so you kind of need that first too, or unless you have the beta version. And then once Google's done with AR Core, we're going to put all that into AR Core so you can use it with Android. And that's all I had. If you guys have any questions, I can answer them. And also, I'll set up a little table over there and have some of these things if you want to play around with them. Sure, go ahead.
When you were dragging around, I noticed that the box kind of wasn't really on the ground. So how do you adjust so that it looks more real, like it's really dragging across the floor, let's say?
Yeah, that's a good question. There's a lot of different ways you can detect a plane, and the one I was doing was a really loose form of detection, saying drag this over anything that even loosely resembles a plane. If you want a tighter dragging experience, you set it so it's a more restrictive drag, so it says only drag this on a plane if you're 100% sure this is a plane. And so it does take a bit of fiddling around with those parameters, and as the tracking algorithms get better, this sort of stuff will also get better.
Cool, thanks.
Mm-hmm. Sure, go ahead.
So you built a pretty complex sort of surface area for developers to use. Are there tools? Is there a toolkit or debugging tools to go along with this? I can imagine some of the 3D stuff is pretty opaque if it's not doing what you want it to.
Right, so we haven't built much in the way of tools for, the biggest pain point with 3D often is placing objects as you want them. And things like hot reloading work really well for that, but it is something we want to work on, is more of like a prototyping tool so you can see what the scene you're creating faster, and also things like replaying through a different set of camera images so that you don't have to actually hold your iPad and walk around the room to test everything. That's a real pain. So yeah, definitely things we want to work on.
So the tracking that's happening, is that done using like pattern recognition, or is it like a mixture of hardware, accelerometers, stuff like that too?
Yeah, the exact algorithm is called visual inertial odometry, and it is a combination of pattern recognition with the motion processor. So they combine the two inputs they're getting, one from the pattern recognition, one from the different motion processors in there to get it to work. And it takes a lot of camera calibration. They have to know everything about the camera to make it work accurately, which is why Google's having a little bit of a harder time doing it. But Google's doing it for like their flagship phones because they need to do it like one camera at a time.
So in terms of competition, just want to ask about WebAsm. A while back, I saw a video where they were shipping, I think it was Unreal Engine with C, just converting it to ASM code, and then they shipped it to the browser successfully. Not production ready, obviously not, but people are actually doing that kind of stuff. So do you think that's like going to do the same thing, or not really?
Like a browser-based AR experience?
Sorry,
so that was happening in VR, and it was going all right. I mean, I think you guys saw Facebook release React VR and things like that, and so you have these rendering engines. They're not as performant unless they're native. So React Viro, similar to React Native, the underlying part is all C++ and native code. When you go to the web, it will be a little slower, and even though ASM is fast. But the other issue is right now, iOS doesn't allow camera access like that through Safari on mobile devices. But I think eventually these things will break down, but native is moving a lot faster right now. Okay.
Last one.